Today we will learn about the inverse norm and normal CDF functions on the calculator. Normal CDF finds the percent of area under the normal curve between points, and the inverse norm function does the opposite, finding positions on the curve based on a given percentile. You know a curve is normal if you can construct a histogram or stem plot and look for it to be bell-shaped and symmetric about the mean. Or you can construct a normal probability plot and look for a linear line. And you can verify the empirical rule, or the problem will just tell you that it's normal. What is the empirical rule, you ask? The empirical rule means that 64% of the data will lie between -1 and 1 for standard deviations, and then 95% will be 2 standard deviations from each side, and 99.7% of the data will be between -3 standard deviations and 3 standard deviations.
Here's an example problem to help clarify. So the problem gives us that scores on a college entry test are normally distributed with a mean of 140 and a standard deviation of 25. Since we know it's normally distributed, we know that we can use the normal CDF function on the calculator. And here's what the curve would look like with the standard deviations labeled. So now, using the information given, we're able to answer this question. What percent of people that took the test got scores between 95 and 170?
Okay, so in order to do this problem, you're going to go through and you're going to sketch a curve. You're going to label your mean and what the problem asks for. You're going to shade in the area to show what you're trying to get. You're going to go into your calculator, into second vars, normal CDF, and do your lower, upper bounds, mean, and standard deviation, which are all given to you between the problems. Paste that, and you have 0.849, which is 84.9% of people who have taken the test, their scores lie between 95 and 170.
Now we have the question, what percent of people that took the test got a score above 155?
So we draw the standard curve again, the mean of 140, and you want everything above 155. So we have 155 and all the way above here. Then we go back to the normal CDF, second vars, and the lower bound is 155. The upper bound, you want to go as high as you can, so you want to go 1 to the power of 99, which is a huge number. And then the mean is 140 from the problem, and the standard deviation is 25 from the problem. So 27.4% of people got a score above 155 in this test.
So now it asks us, what score do you need to get to be in the top 10%?
So you always draw your curve and sketch it, label the mean 140, and what you want to find is the top 10% right here. So you go to second vars, inverse norm, and when it asks for the area in inverse norm, it actually is asking for the area to the left. So if there's 10% above, that means there's 90% below. So you do 0.9 for 90%, 140 is the mean, and 25 is the standard deviation. So this means you need a score of 172.03 to be in the top 10%, or you have to be above 172.
So now it asks us, what score do you need to get on the test to have a better score than 60% of the people who have taken the test?
So you're going to start out drawing your curve, labeling 140 as your mean, and you're going to find 60% underneath the curve. To do this, you're going to go into your calculator, second vars, inverse norm. Your area is going to be 0.60 for the 60%, your mean is 140, and your standard deviation is 25. 146.33 is the score that you'll need on the test to score higher than 60% of the people. I hope this video has helped you learn how to use normal CDF and inverse norm on the calculator.